All right, welcome back to Electricity Quiz Part 2, Open Response. Let's take a look at these now. The diagram below shows a simplified schematic for an adjustable electric blanket. Schematic just simply means what we're looking at here is a drawing of a circuit diagram. The switch can be connected to points W, X, or Y, depending on the levels of warmth. So you see we have different resistance levels here, all right, which would increase the amount of resistance and increase warmth. So A, calculate current generated when the switch is connected to point Y. So if we have our switch connected at Y, what would the current be? So we take our Ohm's law formula and set up for current. As you've already seen in other problems, you know we're going to divide the volts by the resistance. So we see the battery's 20 volts, no problem here. Now the resistance is a bit tricky because as we follow this point Y path, we have 5 ohms, but we also have an additional 12 ohms here over where switch Y would be. So the total resistance is actually 5 plus 12, 17 ohms. So we do 20 volts divided by 17 ohms, and we get 1.17. We'll round it to 1.2 amps. All right, so we got the current. Now calculate the power generated. So we have our formula for power that we've seen earlier. We know the current because we just found it in part A. That's why it was important to get part A. And we know the voltage, 20 volts. So we just multiply, and you should get about 23 and a half or so. And the unit is watts. Remember those units so you don't lose points. Okay, if there's an open at point U, identify what position or positions the switch would allow. So if we have an open in here, the circuit's open, that would basically shut down this entire part. However, we could still have X and the switch connected at W still working, okay? Because this is a parallel circuit, so X and W would still work. However, explain what would happen. So we identified, which means we could just simply put these answers. But to explain, we have to put some writing. What would happen at point, if there's opening at point T here? And as you know, this opening here would be devastating to the circuit because that would shut down the entire circuit, okay? The path would not be complete to get to these resistors. Everything would shut down. So you would just basically say that the entire circuit, would shut down like that. Except you actually write words, but you heard what I said. All right, so nothing would work. It'd be an open circuit. All right, number 2, looking at these electrical components, you had to label and then describe the function. A lot of people forgot to write what they do, but you did have to label. Here's our switch. What's it do? Well, we open or close the circuit, right? So that basically could shut things on and off. What's 3? That's our symbol for resistor. What's a resistor? Well, the word resistor, resists, right? This resists current, right? This is resisting current. So it's slowing the flow of current down. Number 1, what's that? That's our battery symbol. What's a battery? Well, a battery provides the voltage, or if you prefer, a potential difference, kind of like our potential energy here, that basically pushes our current, okay, voltage pushes the current through. All right, sorry about the messy writing, but you hear what I'm saying. You get the gist here. So without the battery, we don't have anything to push. There's no energy to push the current through the circuit. And of course, 4 represents the wire, and this is what connects components. It provides a path for current to flow. So anything like that would have been suffice. If the current in the circuit is 0.5 amps and the resistance is 18 ohms, calculate the voltage. Oh, our simple formula from our formula sheet. Ohm's law, V equals IR, right? 0.5 amps times 18 ohms, 9 volt. Must be powered by a 9 volt battery. All right, describe 2 changes in the circuit that would decrease. All right, you needed 2 decrease, important decrease. So Ohm's law, V equals IR. All right, how do we affect current? Well, voltage obviously is important to current, right? If I rearrange this for current, voltage, so if I want to decrease current, I need a smaller number up here. I need less voltage, less push. So you should have put, less voltage or something like that. And of course, if I increase resistance, you guys saw this when we did that computer lab using the FET simulation. If I increase resistance, I'm dividing by a bigger number, that give me a smaller answer for my current. So then it makes sense because resistance is what's trying to stop the current, right? So if we increase resistance, it's like squeezing that hose when water's trying to get through. Less water gets through if we use the analogy of electricity and water. So increasing resistance would also decrease current. All right, number 3. This is a fun one. You had to draw 4 light bulbs and 2 switches on this, but you had to make sure W and X had the same brightness. Y and Z had the same brightness, but were brighter than W and X. That was crazy. And we'll get to the switch part in a moment. But yeah, so how do you do that? How do you make sure W and X are not as bright as Y and Z and Z are brighter? So what you do is you set up bulb Y and Z in parallel, because as we learned, parallel would be brighter because they're going to get that same voltage from this battery here. And W and X be equally bright. W and X be equally bright because they're in series with each other, but they'd be dimmer. They'd be dimmer because they're in series. They'd be dimmer than these that are in parallel. All right, so that was the trick to do this part. Now for the switches, switch 1 controls W and X, only W and X. So we need switch 1 on the same path as W and X, so that this switch would only shut down this part of the circuit, okay? And then S2, switch 2, controls Y and Z. So how do we have a switch that can control both here and here? Because we need both these paths controlled. Well, we just put the switch over here. This is a good spot for it. All right, put the switch 2 here. That way, when we open it, it would shut down this entire part of the circuit. But this part over here would not be touched by it. All right, so that's basically what you would draw for that one. Cool. Hope you had fun with that.